Okay, we are on the second video for day one, graphing velocity from position. There are 5 skills that you have to take from this video moving forward. So as you go into your lesson in D2L, make sure you're focusing on these things. What we're talking about here is uniform velocity. You know when you have a uniform graph when the line is straight, it is not a curved line. So we are looking at constant speed, no acceleration. This is a uniform velocity graph. And now, to get velocity, we need position or displacement over time. And that's what we have here. Velocity equals displacement or position over time. And remember, if it was displacement, it would just have this triangle, meaning a change in position beside it. The first thing that you have to be able to do is determine displacement from time. So if I said at the 3-second mark, what's your displacement, you would go up to the graph and then you would go across and you'd see your displacement is about 23 or 24 meters. Once again, to determine displacement from time, you go to whatever time they say, you go up to the graph and then you go across. Determining time from displacement is the opposite. We would say, how long would it take for a displacement of 20 meters or a position change of 20 meters to occur? So you go from the 20, you'd go down, and that would take 2 seconds. Now, to find velocity off of a position time graph, and once again, if you look at it, position over time is velocity, so that's what you're doing. You would draw a triangle on the graph and you would take the slope. So, slope equals rise over run, which equals y2 minus y1, x2 minus x1. So y2 would be about 22, y1 would be about 11. Hey, if you need some help with slopes, you're going to have to go into Khan Academy and look at determining slope and do a lesson there to figure it out. Our x2 is about 2.5 seconds and our x1 is about 1.1 second. So it would be 11 divided by 1.4. I'll just do a quick calculation here. And that is about 7.9 meters per second. Those are the 3 calculations you have to be able to do with a uniform velocity graph or a position versus time graph. Now, the other thing that we can get here is I want to show you a couple of other things here while we've got this up. If you want to see somebody who's traveling in a uniform way at a quicker rate, it'll be a steeper line. If they're going slower, it'll be a more shallow line. Slow, medium, fast. Now, for a non-uniform graph or acceleration, what's happening is you're going to get a curved line like this. I'm going to draw this again. So we're still on a position time graph, but if somebody's accelerating, they're starting slowly and then they're speeding up. So here's the 2 things you have to do showing acceleration on a position time graph. Now the reason this is non-uniform is that's not a straight line. So whenever you have a straight line, we call it uniform. Whenever you have a curved line, it's non-uniform. So we're going to do average velocity. And we're going to do instantaneous velocity. To get the average velocity, what we draw is something called a secant. So if we said, what's the average velocity from 0 till the end of the graph, you draw a straight line connecting the two. Ooh, that's a horrible line I just drew right there. But what you want to do, if the question says what's the average velocity from 0 seconds to 3 seconds, I would put a dot on the graph at the 0, a dot on the graph at the 3, and I would connect the lines, and then I would take the slope. So I'm not going to go over slope again. For average velocity, they will always give you 2 times. Let's say the times are 0 and 3. You draw a line between them. Instantaneous velocity from this graph differs in that they will give you a specific time. So they might say, what is the instantaneous velocity at 1 second? What you do is you go to 1 second, you go up to the graph, and you put a dot on it. Once you get that dot on your graph, what you want to do is you want to draw what's called a tangent. Now, a tangent may be the trickiest part of this lesson for people. Once again, if you're not sure what a tangent is or drawing tangents, go to Khan Academy for drawing tangents. But a tangent is a line that only touches the graph at one point. So I'm going to line this up so when I draw a straight line, it just goes through that one point on the graph. Now I'm going to do another tangent at 3 seconds. So I go straight up. I try and draw a straight line that only touches the graph at that one point. So what you can see is this line is steeper than this line. So our instantaneous velocity at 3 seconds is greater than our instantaneous velocity at 1 second. Once again, to get the instantaneous velocity, you would take the slope of that line for 3 seconds and this line for 1 second. When you get an instantaneous velocity question on a position versus time graph where there's acceleration, they will give you one time. For example, 3 seconds. Dot on the line, draw a triangle, take a slope. Now, when you're drawing these triangles, the beauty is it doesn't matter how big these triangles are. You will always get the same answer. So if I draw a triangle on this line that's bigger, this is larger, but proportionally this is also larger. So if you took the slope using this triangle or this triangle, you would get the exact same answer. Okay? So don't worry about the size of the triangle you draw on the line because you're going to get the same answer.